Awesome, thank you. Okay, look, I'm not going to bore you too much with my biography. You can find me online. I'm just going to wait until everybody should see the screen in front of them. Cool. All right, so look, there's a lot to understand about Kafka, and the good thing is, like, as a Java developer, I was a J2EE developer myself. A lot of this stuff is native to Java, like producing and consuming. You'll hear me say a lot of terminology during the session. Look, it's an interactive session. I'm happy to take questions. The other thing is, keep in mind, Kafka, the ecosystem itself, Confluent and Kafka, is massive. So, like, your expectation to understand everything from one session, we should probably just par that down a bit. The intention today is to kind of give you a quick introduction, a 25-30-minute introduction maximum about what Kafka is, what it does, what people use it for. We can run other sessions after this, like we have other speakers, some based in India as well. We can do a streaming talk if you like, and stuff like even specifically to Java. But today it's more about what Kafka is, what it does, the core principles of Kafka. So there's a lot to understand, and I'm happy to take questions during this session, which is deliberately why I keep the length of the slides about 25 slides, because I do expect questions. If you've got questions, just type in chat. I've got chat up in front of me, and I can answer them as we're going during the session. So don't be shy. Feel free to ask. No one's going to know everything first day. All right. So what's Kafka? So I think as a developer, the easiest way to visualize and to understand Kafka is if you think about a traditional database with tables, with rows, and with data inside, that's the most analogous thing to Kafka. So a topic inside of Kafka is analogous to a table. A partition, it's not really a row, it's part of a table. In Kafka also, there's terminology, producer and consumer. This is the thing with Kafka. When something is writing data, that's called a producer. When something is reading data, that's called a consumer. And the really unique thing about Kafka is it's a continuous commit log, which means applications keep writing to it and there's no override. So you can write to Kafka JSON in Avro and anything that's serializable, really. The important thing to remember is once a producer writes a bit of data into your Kafka cluster, anything that cares about that data gets the data real time. So at its core, if you kind of want to boil it down to like a sentence or maybe two sentences, a real-time database is probably the easiest way to describe Kafka. Real-time database meaning the minute you write something, anything that's interested in that row or in that bit of data will see the change real time. So let's use me for example. So me as a customer. So this is my address, but tomorrow I go and change address. The minute I update that address, any application that cares about my address sees the change real time. And this is one of the primary use cases as well. You'll see us meaning Kafka and Confluent, doing things like real-time ETL, which is really not an ETL. It's just a real-time streaming transformation. But to give you an idea at a high level, it's effectively a real-time database with data behind it that is effectively just a large log of files. It's basically one big file system, but it's distributed and it's highly available. So there are things behind here that you don't actually see. Things like replication of data, things like making data highly available, things like the Kafka cluster itself being able to know where a reader is, and if there's failover, to failover to a failover piece of data and serve the data exactly where the reader was, the consumer was. There is a lot to understand about Kafka, but at a high level, producer, consumer, writer, and reader, Kafka cluster, effectively your data store. Okay, so there's another concept called topics. So topics are effectively a stream of data. The example I use a lot is like when you're purchasing something from a company, every time you purchase something, a row gets created. It doesn't get overwritten, right? Because every purchase is tracked. That's kind of how you should think of Kafka all the time. A topic is effectively like a table. So you could have users as a topic, address as a topic, truck GPS location as a topic. The other thing is topics are identified by their name, just like database tables. They're unique. You can't have two topics with the same name. A couple of other things that you need to wrap your head around as well. Topics are actually split into partitions. So the common term is sharding, like in a database, when you shard data sets. This is an information retrieval term. And each partition is ordered. So it's first in, first write, right? And it's the same with the read. When a producer produces data, consumer cares about it, it's effectively, it maintains order. Inside of the topic, a number is given to each message, right? To each bit of data. This is called basically an offset. And this is how Kafka tracks where you're at. Basically what you say is, I'm at this topic, I'm at this partition, and I'm at this offset. And that's how you address a bit of data. It's actually quite unique. You can position a cursor anywhere within a partition and read forward and back as you see fit. So like an interesting use case for this is, like in production and in non-production, typically people have data, like production's reading real time. Non-production is probably 2 weeks behind. So what will happen is production will be at partition 12, and let's say 2 weeks behind is at partition 3, non-prod is at partition 3. You know, it's like, okay, so what do I get from doing this? So you guys should be familiar with like restoring databases and whatnot. Like when you're actually running a test in the dev system, production data is often restored first sanitized to non-prod to simulate data. But imagine not having to do that ever again. That's a really, really unique use case. And I've seen some of our customers use it for that sort of stuff. It's quite powerful in that, you know, you can basically go and retrieve data at any point in time by just, let me just go back one slide. Sorry, I've jumped ahead. By just saying to the consumer, hey, look, go and get this partition and this offset, and this is the data that you should have in your application. This thing here is basically a read application. This thing is basically a write application. Sorry, I think I've got a question. No, every partition has different data. Yeah. To answer the question, no, every partition has different data. Okay, so let me give you an example of a topic. Let's say a truck delivery company that tracks GPS. You send GPS every 10 or 15 seconds. This is added into a fleet. Basically, the use case is telemetry. Where a truck is, what it's got on board, how far it is from the delivery, its location, whether or not it's been in an accident, so in a hazard. So this is effectively like the end user application. But Kafka backs all of this, and it can also back it with a MongoDB thing. Sorry, there's noise in the.
Yeah, apologies for that, Sandy.
No stress. So effectively, let me just go back. So this is a telemetry application. This is the end user application. These are Kafka topics. Real time, this is used to tell the application where your truck is, what the status is, what the location is. But the other thing is, there's something in Kafka called a connector, which will let you connect to things like databases as either a source, meaning it brings data into Kafka, or a sink, meaning Kafka dumps data into it. So typically what we see is a sink source, because you need to be able to do statistics, you need to be able to do historical analysis. Kafka is not a database analytics tool. You need to basically do your analytics elsewhere in your own data lakes or whatever it is. So in this instance, this application is using MongoDB. What happens is, as the data goes into Kafka, it gets dumped into Mongo, and Mongo, or whoever it is that's running an application, can do things like, you know, monitoring, historical analysis, things like, you know, AI trying to figure out the best path of a truck to get from A to B at particular times. Normally here, I kind of ask people to discuss, but there's like 60 people on the call, so I might just skip over that. So let me have a look at some of the questions. What happens when an offset count reaches integer max or long max? Okay, so this is the thing. The internal modeling, or rather than the numbering of the partitions, there's different ways to address it. You can key it differently. You can archive data. By default, what happens is after 7 days, Kafka just goes and and archives data. Two things to really keep in mind. Once data is written, you can't modify the data. Now, I know this is like a concept that's really surreal to people, but Kafka is a continuous commit log, which is effectively used for things like non-repudiation, right? If you need to modify that data, what you do is you put it into another topic and you do stream processing. That's what happens, right? You can't modify data once it's inside of Kafka. That's its nature. I mean, renumbering, reordering, rekeying, you can do that by repartitioning the data if you need to. There's another question. Is it similar to event bus? No, not really. I'll make some slides available after this. Actually, I think I'll share this slide deck with you, and that way you can kind of have a read over it and, you know, compare it to event bus. A lot of people compare it to things like ActiveMQ and a whole bunch of other stuff. The thing is, with Kafka, you're not making copies of the message every time somebody wants to read from it. It's write once, read in many places. That duality kind of only exists in Kafka. Whereas in other traditional like MQ, you need to make a copy of the message. And once something reads the message, it's gone in messaging, right? In Kafka, that's not the case. The message is persisted for as long as you want to persist it.
Sunny, there was a concept of, previewing the message or like using message headers to, choose whether this is a message a consumer wants to consume. Something like that exists in Kafka. Like you you don't consume the message, but you preview it so that should I consume or not, kind of a, a logic could be written around it.
You can write logic around it, but the thing is, if people want to do filtering, as in, so what you're asking for is about the validation of a message, right? Like, correct me if I'm wrong. There's something called schema validation, schema registry. What will happen is when the producer produces a message, it has to produce it to the standards defined by schema registry. And if it doesn't, the message just gets dumped. So you can do that kind of stuff. But that's probably a concept that I would say, like, you would look at after understanding the fundamentals. There are things like dead letter queues as well, because think about it like this. If you want to write a message, but the message is rejected, you still need a copy of that message, because at some point you're going to want to know why it was rejected, right? So you're going to have to put it into something like a dead letter queue.
Yes.
There are all these concepts about message processing and event processing that we can discuss, but that's like a very deep, dark hole.
Yeah, I understand. There are a couple more questions, if you could answer them.
Sure thing. What happens if we need to replay the message after 7 days? You can keep your data around forever if you want. By default, it's 7 days. You can change it to 14. But if you've deleted the data, it's gone. What you should do is you should decide it on archive time. But offset has to reset eventually because Kafka client has offset for long. No, I don't think. Yeah, so it kind of doesn't work like that. I'll send some stuff about offset and partitioning at some point.
Yeah, you can drop me an email and share it with the group.
Yeah, I will, because that's a fairly
detailed topic. I understand. Yeah. I understand that, and probably that's an advanced topic which we can, based on the audience interest, take up later.
Yeah, sure thing. All right, so we'll go through partitions and offsets really quickly. So offsets is basically the way you address a bit of data, right? So I've kind of touched on this before, and I've touched on the fact that it's immutable, but the way you address it is like topic partition offset, right? Like this is basically a key, right? That's kind of how you address stuff inside of Kafka. The other thing is when you're writing to a partition, at any time, you could be writing randomly to any one of these, right? If your producer is producing data, you might go to partition 1 first and then partition 2, unless you key your data, and then it will always go to the same partition. And this is another advanced concept which we can touch on later. But the only thing I kind of want you to understand is that the partitions, you can place stuff in a particular partition if you want, because that's the way you shard data and you rebalance data. But effectively, this is a quick summary of what we've discussed. Like order is guaranteed. This is how you address data. This is how partitions work. Data is immutable. We can talk about cloud in a little bit, but yeah, data is randomly assigned unless, of course, you say, here's the key, and the key always goes to the same place. I'll tell you why people do that. It's because let's say you have a user ID, and that's how you're keying your data. That means whenever somebody has a user ID they want to look up, they know which partition to go to look up this user ID. Then that's kind of why you key, right? To keep all the data in the same place.
Just one question, Sanvi. Is the concept of partitioning similar to what we have in, say, databases, as in we are kind of segregating data so it's easier to look up?
No, so that's a really good question. So the partitions kind of, Kafka itself is distributed, right? What happens is when you can create a topic with a giant partition, but brokers and leaders and sharding, all of that stuff you kind of don't worry about. I mean, some people do partitioning because they want to shard data, right? Like that is possible, but you got to remember there are people that run giant partitions, single partitions with a huge amount of data in it. There's a thing on load balancing that talks about how to partition, because when you partition it, it does increase throughput, right? Because the data is all over the place. But at the same time, that might increase latency because the data is all over the place. It's kind of difficult to say, like it's a decision that was made on performance, because it's kind of not. It's a logical decision. There's some documentation about it, and I'll send. But the short answer is yes, it can make a difference. But typically, what happens is it's a business decision more than it is a load balancing.
Yeah, but it's like a case by case basis that what I want to partition or not, and different clients take different takes on it.
Different approaches, yeah.
Okay.
Thank you. Cool. That's okay. All right. So that was a statement, not a question. Cool. All right. So brokers are basically the things that serve out data and write data inside a Kafka cluster or Confluent cluster, right? So each broker's got a different number. So in this instance, we're pretending there's 3 brokers: broker 101, 102, 103, and each of these brokers have particular partitions. These partitions basically are your data, your live data. So let's have a look at a broker example, and I'll take you through one. So brokers and topics, this is how the relationship works. So each broker here, you can see, has got a partition of a particular topic. What you don't actually see here is each broker has got a replica of each of the other brokers' topics. So should a broker fall over, they can hand over between each other. So broker 101 has got topic A in partition 0. Broker 102 has got a copy of that replica from 103 as well, and it's got its own topic, right? So this is something that we call replication factor. I'm going to go back and forth between these 2 slides. But what you can see here is like live data. This is the actual data that's been written to and read from. But in the background, there are copies of this data across the other brokers. So this was basically, high availability and, failover built into the product. What you're actually seeing here is something that we call a replication factor. When you create a topic, you can create a replication factor. We typically say 3 is the minimum you should be using, because then it's truly highly available. If you have 2, 1 falls over, that's not optimal. So most people create with a replication factor of 3, and the partitions are basically replicated 3 times across the brokers, like in this instance here. So what happens is, in the instance of a broker falling over, another broker, which is called the follower because it was following the other broker, can basically promote itself to a leader, and clients automatically just rebalance to this broker. That's the way Kafka works. You don't have to do any of this stuff yourself. It will just rebalance, and stuff will keep working. So inbuilt replication is there for you as a freebie, right? Like this is a massive deal. Basically what happens is you don't have to worry about all this stuff. All this stuff is built into the product. something happens, your broker falls over, it automatically fails over, and things just resume working. And we've had 2 questions. How's Kafka different from Zookeeper? Kafka uses Zookeeper. So that's about to change. So yeah, it'll be using Zookeeper. Kafka uses Raft, as far as I know. I don't. Yeah, it doesn't use Raft internally. So brokers, leaders, and what we call in-sync replicas. Just to kind of cover this concept again. At any time, the broker can be a leader, which means it's effectively writing and serving out the reads. That broker can share data between other brokers for that partitions. So the other brokers, what we call the ISRs, the in-sync replicas, will sync data across each other. There's a really funny thing in Kafka. When you actually create a topic, what you could do is you can say to it, only serve the data out after the replication has been acknowledged. So let's say, for example, I write in this topic, like let's say this topic is for purchases, my latest purchase. What happens is it sends the data to here and it sends the data to here. It will not serve out the data unless it's these 2 brokers here say, we've got a copy of it, and then it's replicated. So you see the value of that, right? Because there's always the guarantee of replication and the guarantee of order across all 3. So effectively what happens is you've built yourself for, a highly available environment. I might take a second and go through the questions. Okay, so has consistency between brokers achieved? I've just answered that. So basically each broker sends the right confirmation to the lead broker. That's how it's achieved. If we have one partition with 3 Kafka clusters, everything, so explaining how when you connect to a Kafka cluster, you connect to a broker, which gives you the metadata about all the other brokers as well. So it's not really a listener thing. I'd suggest you go and look that up, because basically what happens is a broker gives you metadata, right, about the cluster. And then the client already knows all about the cluster by virtue of the fact that it's metadata given. Okay, so where do brokers fit inside the picture of producers and consumers? Okay, so that's a good question. Let me go back to the start. So producers, consumers, brokers are what run the Kafka cluster. They're inside the cluster. So in this image, the brokers are in the middle. When I say clients, I mean producers and consumers. So we've covered that. We've covered that. Okay. There is the replication between follower, synchronous or asynchronous. I won't go into the mode of replication. It's effectively synchronous, right? Like it'll confirm the writes before it lets somebody read from it. So this is the question that you just asked. Producing data. Producers can receive an acknowledgement of writes. Ax equals 0 means don't acknowledge a write. Ax equals 1, it will only wait for the leader. Ax equals all, it waits for the leader and the followers to confirm that they all have a copy of the data, and then it'll send the next bit of data. Yeah, cool. All right, so that's answered all the questions so far. So effectively what you're doing is data is sharded and replicated across all topics in all partitions, but within brokers as well. And that's the key concept, right? Kafka is already built to give you pretty much everything that you need in a highly available situation and replicant situation. Okay, so we've talked quickly about message keys, but just to touch on it again, when you send a key with a message, it pretty much guarantees that it goes to the same partition all the time. Effectively, the reason you do this is because you want to have all the data about one topic or one item inside this particular partition. So for example, if you're keeping GPS data, you want a key on the truck ID because then it always goes to the same data and people don't have to go elsewhere to get that data. So this answers that question before. It's like, how do you decide between the number of partitions? It's like, well, it's mostly a business decision, right? Okay, so similar to producers and the cluster, Kafka cluster being highly available, there's consumer availability built into Kafka as well. Consumers know where to read from, and they know where to go in case a broker fails as well. Consumer groups is effectively a way of building high availability into your application. So, for example, this is a consumer group, this is a consumer group, this is another consumer group. If a consumer drops from one of these applications, it knows, the other consumer knows where this one was getting its data from and where to basically go and retrieve data in the case of a failure. This is basically, client-side availability. You've got another question. Any limit on number of topics a broker can handle at a time? Kind of yes and no. Like, I mean, if you've got 100,000 topics, yes. But if you're talking about like, is there a hard limit? Not really. I mean, yeah. Okay, so what happens if you have more consumers than partitions? So what happens is, here you've got 4 consumers and 4 partitions. Each consumer will reach from a partition. The 4th one will stay inactive until one of these fails, and then it'll take over its job. So this is overkill. A lot of people don't do this, but there is a need for it sometimes. Yeah, if you're using a consumer group, your throughput of reading increases as well. Okay, so consumers have offsets as well, as in where the thing I read from last was. So consumer offsets are actually maintained inside the broker. So if a consumer falls over, it can tell it where it finished reading the last time when you restart the application. So as an example, this consumer's reading, its committed offset is at 4262. It dies, and then when you restart it, it will know because the broker will tell it, hey, you were at 4262. I won't go into delivery semantics. There's something I did want to explain though, like it's called idempotence. Basically what it means is a mathematical operation that says, I can run the same function over and over and it will result in the same output all the time. If you should be familiar with this term as a developer. So idempotence, you can have that in Kafka. You can have exactly once, only once, and at most once. 3 delivery semantics. So when you send a message, you have the option of doing one of these 3. Very important in things like transactional banking and stuff. But there are times where you might need at least once. Again, this is a business decision more than anything else. My advice would be like, we can sit here and talk about it, but have a read of this. This is one of those slides where you kind of want to go away and have a read. Okay, so I spoke about this before. What happens is when you connect to a client, to a Kafka cluster, metadata is what's fed to the Kafka client, basically a list of all the brokers. And then if anything happens to this broker, it can connect to any of the other brokers. So we kind of touched on this before, but this gives you an example of what it looks like. So we talked about Zookeeper quickly, but Zookeeper is about to go away. This is probably something you should be aware of, but not really bother too much about. Zookeeper will disappear soon.
Just one question. Sorry to interrupt, Sanvi. What's Zookeeper being replaced by?
It's effectively an internal thing. Okay. I'll bring up a slide after this. Yep.
Yeah. Thank you.
Okay. Just before I wrap up, I'll talk to you about the importance of Kafka as a concept. The thing is, your takeaway today, right, shouldn't be like understanding how Kafka works internally. It should just be, this is what it guarantees, right? the thing that most is guarantees order of data, guarantees data is not going to be deleted, guarantees delivery of data as well, fault tolerant, resume where you left off as a producer or as a consumer, delivery guarantees once off, so exactly once, at least once, and what was the other one? Most once. So yeah, so these are the guarantees you kind of need to understand as a developer. The thing is, Kafka itself is a tool, right? It's a means to an end. It's not really, hey, I'm going to go and learn Kafka. It's what you should be doing is learning how to write and solve business problems in Kafka. So how do I solve for an application that needs to know where trucks are and that sort of stuff? How do I solve for this, or how do I design for this application? It's a tool like anything else, yeah. That's a good question. When a consumer connects back to the broker, how does it know it's the same consumer that's previously fallen off? So like there's metadata about consumers as well, like applications. So when an application starts reading stuff, there's metadata about it as well. Actually, I'm going to encourage you to go and look that up because the answer to that is actually quite interesting. It's quite cool. So look, I'm gonna wrap up there. I try to keep it to 25 minutes. I think I went a little bit over. Yeah, that's okay though. There's a couple of things that I like to encourage you to do. Like you can sign up to Confluent Cloud for free. You'll get $100 worth of credit, I think, for the first, or $200 for the first 3 months, which is effectively like $600. If you sign up using a basic cluster, don't use standard and don't use dedicated, you can effectively just play around and learn how to write an application for ostensibly what it's free. It's a really good learning exercise. And the other thing is, on the Kafka website, there are free books. There's the Kafka Bible. I would suggest you go and grab that. That is a really good read, but it's very thick. It's like 500 pages. That's a great place to start. Yep, confluent.io/download. So look, I'll send some use cases through, like we talked about GPS. I'll give you a high level, like let's say 10 use cases. So real-time tracking, real-time inventory, fraud detection at POS, real-time banking, interbank banking, B2B banking, utilities, power. Couple of our customers use it for things like customer notification, real-time, customer 360, insurance. Yeah, a whole bunch of different things.
Sunny, do you by any chance have anything available now to just quickly walk through in case by any chance?
I haven't prepared anything.
Okay.
I can have something next time, or I can have one of the other SEs in your region present something next time about a use case.
Absolutely, yeah. There were a couple of questions. I'll just quickly go through them. One question was that, are the topics fixed for producer or decided by the producer at runtime? This is a question from Praveen.
What does that mean? As in, can you dynamically create topics? Is that what it is?
Praveen, could you chime in?
Okay. The producer decides what topic he wants to. There may not be a topic already existing. Can he dynamically just say, okay, I just want to send the message to this topic?
Yeah, so you can dynamically create topics, but the problem with that is then, here's the thing. If you dynamically create a topic, how do you validate what's going inside? So it's like this, right? Think about it like in the traditional database term. How often do you dynamically create a table for a topic or a bit of data? I know there are use cases for it and you can do it, but I'm just saying it's very dangerous territory. The short answer is yes, you can, but be very careful if you decide to do that.
Sanjay, I'm not sure what are you trying to address Praveen's question that Spring Cloud Kafka Stream has routing capabilities.
I think he's basically saying the same thing that I said. You can create topics dynamically. Yeah.
Okay. The couple of questions from can Kafka store time series data? Basically getting into monitoring territory.
Yes, it can. But I mean, it depends on what you're talking about, right? Like data is data. if you can put it in JSON or Avro, you can store it in Kafka, right? If you can serialize it, you can put it in Kafka. That's what it comes down to.
Okay, another question is, will Kafka restore data in case of power failure for broker?
So this is the thing. If a broker fails, we'll go back to the example. So you guys, you'll have to imagine the brokers again. So brokers are usually distributed across data centers and across availability zone. So if you have a power failure, the other two brokers are still up. That's how it works, right? Because what happens is the in-sync replicas in the data is replicated across data centers. The concept is actually called a multi-region cluster, where you have bits of the cluster in different parts. And that's the entire strength of it, right? Because you spread across data centers. If power goes down, it doesn't matter. The other brokers are still up.
Okay. By any chance, do you remember any, at least a name for a use case for the insurance industry, where insurance industry is using Kafka for any business to solve a business problem?
Customer 360.
Okay.
So when you have an insurance product, let's say you have insurance for health for your family, and then you want to do your car. The part of the company that does insurance for the car is different than the one that does health.
Okay.
So customer 360, as in single user ID across different departments, is pretty common for us, so especially across insurance.
Okay. If there are any, I believe best practices or other, I believe I'm reading the word bad as best, Raghavendra. So correct me if I'm not wrong, or something like do's and don'ts probably around Kafka. That's what I think Raghavendra is looking for.
Look, it kind of depends on the problem you're trying to solve. The best, there's load testing stuff and there's tuning stuff on our website, white papers that you can just download. So I'd suggest reading those. That will tell you, how to tune and how to write good apps.
Okay. Okay. There's a question here. This is more on the monitoring capabilities provided out of the box by Kafka, where you can monitor the count of the messages in a partition for a topic, or the read commits. I mean, any kind of monitoring capabilities provided out of the box.
There's one in Confluent. It's called Control Center.
Mm-hmm.
I believe that's open source, but it's not. So our open source license is unique. Like, it's free to use, but you can't kind of sell it. Go and have a look at our open source license. A lot of the stuff that we talked about is available there. But yeah.
You were talking about the Confluent dashboard, this thing, right? Dashboard.
Yeah, Confluent Control Center. Yep.
Control Center. Yeah. So yeah, I think hope that answers your question, Sudhakar. Okay. Okay, here's another question, that can you specify data locality? So like if I believe Raghavendra we're talking about is, if I have a multi-region or a multi-data center cluster, can I specify which data resides where?
Yeah, exactly. Yeah.
Why? So you wouldn't want to do that. And the whole point of having a cluster is, like, you don't have to deal with locality. It should all be the same in terms of latency and hardware. I mean, if there's data locality issues, what you should do is set up a Kafka cluster only in that region and then replicate the entire cluster to somewhere else. So there's different ways to address that problem that you're trying to solve. It's probably best to tell me what problem it is that you're trying to solve, rather than like the solution to the problem. Because it sounds like if you have a latency issue, is that what you're asking about, latency?
Not exactly. If I want to set up a multi-region, cluster spanning across, probably east and west coasts. So is it possible to set up a cluster in that setup? And to go a level lower, if I have to specify, I need so and so partitions in so and so machines in different racks, etc. Is there a provisions while deploying cluster to specify this kind of?
Kafka is rack aware. I think what we'll do is we'll probably run a different session about this, because replication and cluster and being like rack aware and data center aware, that's a very, very difficult distributed problem scenario. But the short answer to your question is you shouldn't have to. But yes, I understand there may be situations where you want to, but then what you're doing is you should be setting up multiple Kafka clusters rather than brokers. But we can look. We
Okay.
can have another session. We can talk about that. Yeah.
I believe Sanjay's question is also related to Kafka clusters, which becomes a more advanced topic because he's talking about, reading the data twice, because if it's like being connected or the client is connecting to multiple clusters, something of
No,
that
so,
sort.
no, so this is the thing. NA1 and NA2 data is synced. If you produce the message to NA1, it won't get consumed twice because the broker will not let the message leave until all the replicas have a copy of that message. And this is why I talked about that guarantee of delivery before. Exactly once, at least once, and I think, was it the other one, most ones. So get the guarantee is delivery, and the configuration of your messaging and your topic is important. So this has got to do with rather the topic configuration.
Okay, I have pasted the link to the control center for the audience, so they can have a look at it if you want to explore it. There was another question about how message queues streams of data in Kafka differ fundamentally in the context of event-driven architecture. Shivakumar, can you quantify the question a bit more, because it seems too generic. Do you want to unmute yourself and probably quantify what you want to understand better?
Yes, right. Yeah. My question originally lied like I thought Kafka is just streams of data which producer produces and we consume it, but it is more to it, seems like. So because when the concept of replace and all comes, so how is that differing when in comparison with the message queue, right?
So,
I think sorry, go ahead. Sorry.
Yeah, that's a good question. The thing is, it's fundamentally different to a message queue. Kafka is event driven. Confluent is event driven. That's the entire thing, right? Because it's an event that goes into a system and comes out. I'm gonna have to go soon because I've got a thing on shortly. I'm more than happy to come back at some other point and take further questions. But look, that's a good question. It is event driven architecture, but the way that it works internally is not the same as we're used to traditionally, especially with messaging. Like if you think about messaging, once a message is sent, it's basically a set of electrons, right? And once the message is consumed, that's it. That's the end of it. Like you never see that thing again. Kafka is different. Once a message is created, it's there forever or until you delete it. And it's immutable, which means you have the original message. And if more than one thing wants to consume it, you don't have to make copies. You can process it in flight. You can enhance it in flight. So think about it like this, right? Let's say, so Suvik and I, we collaborate across the world. Every time I want to write a bit of data, Suvik wants to enhance it or enrich that data with something else. He can write a real-time streaming transformation to enhance that data and do whatever he wants with it without having to make a copy of that data. But what will happen is he will have his own topic and his own partitions and etc. and basically do that. Like I'm using that as an example, but if you think about us as two different business units within an organization, the data is there for everybody to use. Like the term is democratization of data. Let me just type that into chat. It's basically liberating data so that everybody within an organization can use it and enhance it and do what they want with it. So when data comes into the pipe, everybody has access to it at the same time. Think about a traditional database, right? If a customer signs up to my health insurance part of my business today, and my auto insurance wants access to that customer data, I have to go and create an ETL overnight and dump that data, what was created today, into that car insurance database. Now, for every other business unit that wants a copy of that data, I have to do the same thing over and over and over again. Whereas with Kafka, the minute it gets created, any BU that subscribes to that topic has access to it, and they can do what they want to it real time. It's a very different way to look at things. It is event driven, and that's kind of the point I want you to take away. But it's more powerful than just messaging. What we'll do is like I'll see if I can speak to Joe and get one of the local SEs in India to give you guys like a streaming.
Yeah, absolutely. I think that given the interest from the audience, we'll probably plan a 1 or 2 session, or 201 rather. A couple of quick things. Thomas, when you talk about distributions, I believe you're talking about flavors. So you can go on to Confluent and check out, or is there a better place to find out the distributions?
Yeah, no. So So there's like by distributions, like there's open source and there's Confluent. Yeah. Oh yeah. And there's variants out there. There are people that will roll their own Kafka and stuff, but it's not. Here's the thing. It'll be versions old of Kafka. If it's not distributed via open source or us, we contribute like 80 to 90% of Kafka code. Like the company Confluent, who I work for, 85% of the code that's in Kafka comes from us. Like we maintain and we publish the open source product. We're also a private company that do our own thing, but like open source Kafka is the most up-to-date Kafka that you'll ever find. That's the best place to go in terms of like flavors or whatever.
Okay. Does Kafka support millions? Okay, sorry. How many? Can you give me 5 more minutes more?
Yeah, so look, I'll answer that question, and this one will probably take 5 minutes. Anyway, so in terms of like size of Kafka, I'll give you a couple of use cases. So Lyft, Uber, Epic Games, you're talking about teraflops of data daily that go through Kafka. All these guys use Kafka. Epic Games use Confluent, Confluent Cloud, in fact. So like in terms of size of data and processing capability, it was effectively built to address the infinite data problem, right? And the real-time messaging problem. Kafka at the moment, where it's evolved to, there's a couple of features. One of them is called infinite storage, where you can store a ton of data. You can do things like do compression of data, where you basically just turn on a flag that says compress and you get 70% benefit for nothing. So basically your data reduces to 30% of the size that it was before just by turning on a compression flag. There are things that are Kafka native that are designed for like high throughput, high volume, large data, fast data, and commodity hardware is the other thing. I saw that question come up before. It's like, well, yeah, you can do it. The intention is to do it on commodity hardware. You don't need to go out and buy like a Solaris machine, an Oracle machine, or whatever. You can use EC2 instances if you want, like a whole bunch of them, to basically do what you need to do. There's another question. Good certification courses. Yeah, they're all on our website. I think they're relatively cheap, the online ones. There's also Udemy. Let me list the guy's name. Actually, I'll find his name.
Stefan Marek.
Yeah, some of those Stefan Marek, but there's another one as well now. He does it. I forget his name. Simon something or other. But he does a course with somebody else that's also pretty good.